18, I don't know if this is right or not, 1802.8.
2.8?
He said 18 point.
1802.8, but I'm not sure if that's right or not.
It's easy, guys. This is 400.
18.2.8.
This is 2,000
Yeah, yeah.
divided by 2 is 1,000. 1,000 divided by sine of 33. 18?
I punched in my calculator real fast.
18.
Same as I got.
Do I need to find CXCY? No.
No.
The question asked me about the cylinder. So the way I can break it down to go through it, that's all I need. Okay, let's move to the next. And again, you are not going to expect a question that was not solved in the, these are friction questions as well, friction questions. This is another question from chapter 2 or 3. The frame ECG, whatever, to find the moment about diagonal. When we deal with moment about diagonal, the best way is to do the
Mixed product.
mixed product. And the mixed product is going to be, for this problem, lambda AD. Lambda AD. Lambda AD. I, J, K. Then distance, correct? Distance from the moment where we need to calculate the moment. And if I am calculating the moment, I'm looking at this distance on x. If I calculate the moment here, I need to take this distance. So it's easy, I will go, distance going to be AB distance, or AB, which it is 400. This one. 0, 0. Then the force, correct? Force on I, force on J, and force on K. This is the matrix that you need to build. In order to find, let's start. Lambda. Lambda, in order to calculate lambda, line AD goes from A to D on X, how much? 800. On Y, 0, correct? On J,
600.
negative 600. This is line from A to D. AD as magnitude is going to be the square root of 800 square and 600 square, which equal 1,000, correct? And now the lambda AD, which it is the unit vector, correct? Is going to be, this is over 1,000. This is the lambda. Done? Distance, RB, from A to B. R from A to B, I'm going on X for 400 millimeter, or 0.4 of a meter. Agree? Let's go to the force now. Which cable we are talking about? Knowing that the cable is defined, the moment from AD, from A by the BG, BG. I'm looking at this cable now, correct? Let's write the as distance from B to G on X. On X, what we go? Negative 400. Agree? On Y,
740.
positive 740. On K,
320.
negative 600, positive 280 is a 320. Negative. And BG as a magnitude is the square root of 400 square, 740 square, 320 square. Give me a number, please. Then lambda BG equal negative 400 I positive 740J negative 320K. Any number in here, please?
900.
900
Yep.
over 900. And finally, the force in this BG equal, how much is the tension in the cable? 1125 times lambda BG. So now do 1125 times 0.4. Let's go with this as 0.4, 0.74, 0.32 to deal with meters, over 0.9 to deal with meters. And give me numbers, please. 0.4 over 0.9.
Times 1125 is
How much?
500. You got 500 I.
0.74 over 0.9 times 1125 is
925.
925.
Yes.
0.32 over 0.9 times 1125.
400.
This is the force in a Newton. This is force BG or
That
TBG.
500 should be negative.
This,
No, the first one.
and this is on K. And now finally, I need just to place it in a matrix. The matrix says the lambda started with lambda 0.80, negative 0.6. The distance is 0.4, 0, and 0. Negative 500, 925, negative 400. Copy 2 columns. And let's start. 0, 0, 0.4, 0.6, 925. 0.6 times 0.4 times 925 is a negative. This one. Now everything after that is going to be negative. 0 here, 0 here, 0 here. Correct? What is the number in here?
Negative 222.
222. And this is in Newton meter. This is the moment about that. Now,
Sorry, just the one.
these steps here, 1, 2, 3, 4, you can write it directly in one step, correct? The force equal 1125 times this number over the magnitude in one equation, and you get the answer. Or you can write 4 equations. Questions on this? Questions on this? I didn't drink water.